Chapter 6.3, Day 2, Logarithms and Logarithmic Functions. So here we're going to focus on evaluating logarithmic expressions. So remember from the previous lesson that log base b of y equals x is a logarithmic form, and an exponential form is b to the x equals y. So notice the base is b, and notice where they are in each form. And then the x here, so x is the exponent here, and logs equal exponents here, and then our y value goes there. So we're going to evaluate log expressions. Evaluate the log expression of log base 4 of 64. So to help you find the value of log base b of y, ask yourself what power of b gives you y. So what we want to do is let's go ahead and rewrite it in exponential form. So rewrite it in exponential form. And so we know that the base is 4. And so we're trying to figure out what is it equal to. So what is the exponent it equals to? And that should equal 64. So 4 to what power is 64? Well, that's 4 to the third equals 64. So therefore, our x equals 3. So let's try another one. We have log base 5 is 0.2. So another way to write 0.2 is 2 over 10. And 2 over 10 is 1 over 5. So we're really looking at what's log base 5 of 1 over 5. So 5 to what power equals 1 over 5? So it's in the denominator position, so I hope you see that x is -1. So in order to get this, 5 to the -1, remember that 5 to the -1, you flip it, and so it's 1 over 5, so that is true. So I want you to go ahead and try the rest of these. So rewrite it in exponential form first, and then find x. So if you tried it out, these are all the answers you should have gotten. So for log base 1/5 to 125, then you rewrite it 1 over 5 to what power equals 125. And of course, you should probably put parentheses here to kind of help clarify what you're looking at. And so that is -3, and then the next one is 2, and so forth. So now we want to evaluate logs, or we want to take a look at what's called a common logarithm and natural logarithm. So a common logarithm is a logarithm with base 10. So here previously we were looking at different bases. So we had base 5, base 6, base 4, for example. And so we want to be able to identify what is the common log. So it's denoted by log base 10, or really it's simply by just log without anything. So if you don't see anything there, it is assumed that it's a 10. Now the important part about this is that this is what's on your calculator. So if you do not have a base 10, then that's not what's on your calculator, and we have to do something else. So what I want you to recognize is a log base 10 of x is the same thing as log of x. So it's assumed that if there's nothing written here that it is base 10. Now, natural logarithm, that is a logarithm with base e, and we talked about e in one of the previous lessons. Natural base e has to do with continuous growth, and so it can be denoted by log base e, but is usually denoted by ln, lowercase l and n, natural log. And so what this looks like is log base e of x is the same thing as natural log of x. And so again, this is what's on your calculator. You'll see a natural log, an ln, on your calculator. So knowing that, we're going to take a look at evaluating each using a calculator. So if you're using one of the gray calculators, the TI-30XA, then what you have to do is you plug in the number first and then press log. If you're using like the pink calculator, TI-30X2S, then you're just going to type in the log and then 8 and then equals. Okay, so that's for the pink calculator. Let me rewrite that. So for the pink calculator, the TI-30X2S, you're going to press that log button and then 8 and then equals. For the gray calculator, the TI-30XA, you have to press the number 8 first and then the log or the natural log button. So what you're going to do is go ahead and do that, and you're going to round to 3 decimal places for each of these, so knowing how to use a calculator. And so if you plug in log base 8, you should get 0.903. Then letter B, natural log. So make sure you press the actual natural log button. And then when you do that, you get negative 1.204. So try the rest of these, and actually please ignore number 9 because you can do that without a calculator. I mean, you could use a calculator, but you'll see what you get, but hopefully you know how to do that without a calculator. So try the rest of these. All right, if you tried these, you should have gotten for letter B, I didn't give you that one. Oh, I did, is negative 1.204. So below it, log base 10 of 12 is 1.079. And then you get the various answers here. So 9 and 10 you could evaluate without a calculator. Remember to rewrite that. That's 2 to what power equals 32. And this is 27 to what power equals 3. And then, so we know that because this is smaller here, so 27 cube root of 27 equals 3, and the cube root of 27 you can rewrite as 27 to the 1/3. Okay, so I hope this helps you out.